Hi everyone, I'm Huang Yulong, and this is my X404 custom feature final demo. This week I added several new features to my runtime editor. First, I added a selection highlighting. When I click on different tabs or actors, they will get automatically highlighted, so it's very clear what is currently selected. Let's try to click on Donna. Donna is highlighted. Let's try other enemy. Enemy 2. They both work fine. We can also directly click on the actors themselves. Donna, enemy, enemy 2. This is my first feature. For my second feature, I also support adding and deleting actors and components during runtime. Deleting is very straightforward. I can just click the remove button here next to a component. Let's try to click the sprite renderer here. And we resume the game to see what is going on. We can see that the Donna is invisible right now because we just deleted the sprite renderer. Let's add the sprite renderer back. Okay, you can see there are two input fields here. Basically, there are two ways to change the sprite in the sprite renderer inspector. First, I can manually type a sprite name into the input field here. Let's try Donna 1 and resume the game. Okay, the sprite is back. And secondly, we can also use the drop-down menu here. It basically lists all the available images scanned from the resource folder. We can change to Donna 2. We can also change the sprite during the runtime. Let's pause here. I will show you the code of the sprite renderer here. Okay, here's the code. This part of the code handles sprite changes in the sprite renderer inspector. As I just showed you, there are two ways to change the sprite. You can either manually type a sprite name into the input field, or you can select an item from the drop-down menu. So in both cases, the sprite change happens immediately because the inspector is directly modifying the component's running data. And the rendering system reads the value every frame. So the visual results is updated instantly in the scene. After adding and deleting, we can also create a new actor from scratch. We can click the add new actor button here, and we can also freely, let's give it a name. Let's call it test actor. This is the completely new actor created from the editor. We can also add a component. Let's add transform and add sprite render for our visualization. Let's pick enemy 2. And you can see there's a little green box here. This is because the default transform is 0.0 right here. We can set it to a proper place and resume to see what is going on here. So this is the actor we created right now. But up to this point, everything I've shown is only modifying what we see in the play window in our editor. Nothing is actually written back to the memory. So naturally, we need a way to persist these changes. For that, I introduced an edit mode, which can only be enabled when the game is paused. The button is gray right now. It's paused and the edit mode is enabled right now. So let's turn it on. There are two buttons right now, and I can either save or discard my changes. If I click save, all the modifications, including the transform changes, sprite changes, and any components I added or removed, are written back to the scene file. For the demonstration, let's click the discard first and reset.
Mission start!
Okay, the game is reset to the beginning state right now. We discard all the changes we made. And now we can try to modify the values and also the sprite renderer, or the sprite. Okay, guess we cannot change the sprite right now. Okay, let's save the changes and reset.
Mission start!
Okay, we can see the beginning position of Donna is changed. We can also add a new actor and save the change. Test the actor. Transform, sprite renderer, NM3 this time. And save. And reset.
Mission start!
Now we have the created actors with us right now. Let's back to the code. Here, this function saves scene to file. This function basically saves the current scene state back to the JSON file. It's the error checking, and it will also read the JSON file into a rapid JSON document and make sure the file contains a valid actors array. That's error checking. After that, it builds a map from actor name to the in-memory actor instance. Here. And next, it iterates through every actor already in the JSON scene. For each one, it finds a corresponding in-memory actor by name. If there's no match, it just leaves that JSON actor unchanged. Once it finds a matched actor, it makes sure the actor has a component. It's also the error checking right here. And here are the updating logic. First, it removes components that exist in JSON but no longer exist in the memory. That handles the deleting components. Second one, it updates components that exist in both places. For each of those, it actually clear the old JSON value and replaces them with the new JSON value. The third one, it adds any components that exist in memory but are not in JSON. This part handles newly added components. And after updating all existing scene actors, the function needs to handle the editor created actors. It is this part of code. For each new actor created in the editor, it creates a new JSON actor object and add it to the JSON actors array. And finally, after everything is updated, it writes a modified JSON back to the scene file. Yeah, that's it. So in conclusion, this system works like a very lightweight runtime editor. It supports actor selection, drag and drop interaction, components editing, and save anything changed into the memory. Thanks for watching.